Welcome viewers, I am Venkatesan. Today my lecture is about normal distribution. The question is, find the moment generating function of normal distribution and hence find its mean and variance. Since normal distribution falls under continuous case, we should define probability density function of normal distribution. That is, f of x is equal to 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu divided by sigma whole square. Remember, where here x minus mu divided by sigma, which is equal to z, is nothing but standard normal variate. Now we are going to determine its moment generating function. As usual, the formula for moment generating function is mx of t is equal to expectation of e power tx, that is integral minus infinity to plus infinity e power tx into f of x dx. I am replacing f of x value here, which is 1 by sigma root 2 pi e power minus 1 by 2 into x minus mu divided by sigma whole square. Here, this 1 by sigma root 2 pi is constant. You can take it common here. The remaining terms are integral minus infinity to plus infinity e power tx into e power minus 1 by 2 x minus mu by sigma whole square into dx. We cannot integrate this easily. We are going to use substitution method. The substitution is given as x minus mu by sigma is nothing but z. That is standard normal variate. If z is equal to x minus mu by sigma, then dz is equal to dx divided by sigma. At the same time, we should check the limits also here. X limits varies between minus infinity to plus infinity. Then how about the z limits? Because we are converting all x variables in terms of z here. If x tends to infinity, z tends to minus infinity. If x tends to minus infinity, z tends to minus infinity. Similarly, if x tends to infinity, z also tends to infinity here. Similarly, here z is equal to, I'll write here, z is equal to x minus mu by sigma, which means x minus mu is equal to sigma into z, which means x is equal to sigma z plus mu. Similarly, what will be dx? While differentiating this, you will get sigma into dz. That only I have written here. Now substitute all these entries in the above integration, that is in this integration. That is 1 by sigma root 2 pi. Integrations, the limits are same, e power sigma, replacing this x value with sigma z plus mu. So here sigma z plus mu, e power minus 1 by 2 into this power will be z square that we already assumed here. That is equal to e power mu t divided by root 2 pi. Of course, here the sigma term get cancelled with the term here. Sigma get cancelled with the denominator. So e power mu t divided by root 2 pi integral minus infinity to plus infinity. You just multiply this t inside e power t sigma z. E power t mu also comes, that I am taking outside here, which is e power mu t into e power minus 1 by 2 into z square dz. The next step, I am taking the powers here, e power t sigma z minus 1 by 2 into z square into dz. That is equal to e power mu t divided by root 2 pi. We can take minus 1 by 2 common in the power, so this will be minus 1 by 2 z square minus 2 sigma tz into dz. This also we cannot integrate easily. So I'm just adding and subtracting sigma square t square here, which means the first three terms will be in the form of z minus sigma t whole square. Actually, this is very important in this derivation. We can rewrite first three terms as z minus sigma t whole square into the last term, that is e power sigma square t square divided by 2, because minus 1 by 2 into minus sigma square t square will be e power sigma square t square divided by 2 into dz. The next step, this will be rewritten as e power mu t into, here it is constant because we don't have any z variable, so we can take it common, e power sigma square t square divided by 2 whole divided by root 2 pi integral minus infinity to plus infinity e power minus 1 by 2 into z minus sigma t whole square divided by dz. Now we are going to integrate this. Before that, you just take the power here, e power mu t, e power sigma square t square by 2 will be rewritten as e power mu t plus sigma square t square divided by 2 whole divided by 2 pi integral minus infinity to plus infinity. It is in the form of e power minus x square divided by 2 into dx. That answer is root 2 pi. So you replace this entire integration with root 2 pi and cancel it with denominator. The formula, the answer for moment generating function is e power mu t plus sigma square t square divided by 2. How to determine mean and variance? As usual, in while determining mean, we should differentiate moment generating function once and apply t equal to 0. So e of x is equal to mx dash of t at t equal to 0. That is d by dt of mx of t at t equal to 0. Here wherever you have t terms, that only you should differentiate. E power x differentiation is simply e power x. This power differentiation is here. Mu t differentiation is mu. T square differentiation is 2t. So 2 sigma square t divided by 2. These 2 get cancelled with the numerator. When you apply t equal to 0, you will get mu alone. Similarly, we should determine e of x square, that is differentiation of mx of t twice, that is mx double dash of t at t equal to 0. First time differentiation answer that we have already. When you differentiate it again, you will get mu square plus sigma square. And we know that variance of x formula, e of x square minus e of x whole square, that is mu square plus sigma square minus mu square. We can cancel plus mu square with minus mu square. The answer will be sigma square, which means in normal distribution, mean is mu and variance is sigma square. Thank you.